CELE Refresher, MSTC. Past board exams. Applied Mathematics, Surveying, Principles of Transportation and Highway Engineering, Construction Management and Methods. Problem 1. A farmer owned a square field measuring exactly 2,261 yards on each side. 1,898 yards from one corner and 1,009 yards from an adjacent corner stood a beech tree. A neighbor offered to purchase a triangular portion of the field, stipulating that a fence should be erected in a straight line from one side of the field to an adjacent side, so that the beech tree was part of the fence. The farmer accepted the offer but made sure that the triangular portion was a minimum area. How long was the fence? 2,018 yards. Problem 2. The number of hours daylight d of t at a particular time of the year can be approximated by d of t equals to k over 2. Sine of 2 pi over 365 multiplied by t minus 79 plus 12 for t days and t equals to 0 corresponding to January 1. The constant k determines the total variation in day length and depends on the latitude of the locale. When is the day length the shortest? Assume k equals to 6. December 20. Problem 3. A mountain peak A is 1,040 meters above sea level. From mountain peak A, the angle of elevation of mountain peak B was 10 degrees. The pilot of Air Asia, upon flying directly over peak A, took the angle of depression of peak B equal to 46 degrees 12 minutes and read his altimeter to be 2,820 meters above the sea level. Determine the elevation of mountain peak B. 1,297.45 meters. Problem 4. Morning peak traffic upstream of a toll booth is given below. The toll plaza consists of 3 booths, each of which can handle an average of 1 vehicle every 6 seconds. Determine the total delay in vehicle per minute. 8,000 vehicle per minute. Problem 5. The local weather forecaster says no rain, and his record is 2/3 accuracy of prediction. But the Federal Meteorological Service predicts rain, and their record is 3/4 with no other data available. What is the chance of rain? Probability of rain is equal to 3 over 5. Problem 6. A new kind of atom smasher is to be composed of 2 tangents and a circular arc which is concave toward the point of intersection of the 2 tangents. Each tangent and the arc of the circle is 1 mile long. What is the radius of the circle? Use 1 mile equal to 5,280 feet. 1,437.50 feet. Problem 7. Near the town of Lunch, Nebraska, there is a large triangular plot of land bounded by 3 straight roads, which are 855, 870, and 975 yards long, respectively. The owner of the land, a friend of mine, told me that he had decided to sell half the plot to a neighbor, but the buyer had stipulated that the seller of the land should erect the fence, which was to be a straight one. The cost of fences being high, my friend naturally wanted the fence to be as short as possible. What is the minimum length in yards the fence can be? 600 yards. Problem 8. There are 4 towns at the corners of a square. 4 motorists set out, each driving to the next clockwise town, and each man but the 4th going 8 miles per hour faster than the car ahead. Thus, the first car travels 24 miles per hour faster than the 4th. At the end of 1 hour, the first and third cars are 204, and the second and fourth 212 beeline miles apart. How fast is the first car traveling, and how far apart are the towns? 50 miles per hour, 180 miles. Problem 9. Calculate the benefit-cost ratio for a highway project with the following benefits and costs. The project life is 40 years, the interest rate is 10%, and the project's right-of-way is worth $5 million in 40 years. Construction cost includes acquiring right-of-way equal to $20 million, annual maintenance equal to $350,000, repaving every 8 years equal to $3 million, annual value of lives saved equal to $1 million, time savings for commercial traffic equal to $1.25 million, time savings for commuter and recreational traffic equal to $1 million. 1.23. Problem 10. Find the expected production in loose cubic meters, LCM, per hour of a small hydraulic excavator. Heaped bucket capacity is 0.57 cubic meter. The material is sand and gravel with a bucket fill factor of 0.95. Job efficiency is 50 minutes per hour. Average depth of cut is 4.3 meters. Maximum depth of cut is 6.1 meters, and average swing is 90. Hint: production LCM per hour equal to C multiplied by S multiplied by V multiplied by B multiplied by E. 113 loose cubic meters per hour. Problem 11. A crawler tractor weighing 36 ton is towing a rubber-tired scraper weighing 45.5 ton up a grade of 4%. What is the total resistance of the combination if the rolling resistance factor is 50 kg per ton? 5,535 kilograms. Problem 12. A power shift crawler tractor has a rated blade capacity of 7.65 LCM. The dozer is excavating loose common earth and pushing its distance of 61 meters. Maximum reverse speed in third range is 8 km per hour. Estimate the production of the dozer if the job efficiency is 50 minute per hour. Hint: fixed time equal to 0.05 minute. Dozing speed equal to 4 km per hour. Production equal to volume per cycle multiplied by cycle per hour multiplied by job efficiency. 271 LCM per hour. Problem 13. A chain was used to check the distance between two control points on a large building project. The distance was measured and recorded as 600.172 meter. After the work was finished, it was decided to check that chain at the location baseline. Upon checking, the chain was actually 29.992 meter rather than 30 meter. What is the actual length between two control points? 600.012 meters. Problem 14. A construction surveyor measured the length between two control monuments with 50-meter chain. One point was at the bottom of a hill, and the other was on the side of the hill. A slope measurement was made by holding the zero end of the chain at the center of the instrument and reading 45.290 meters at the point. A zenith angle of 75 degrees was made to the point. Find the horizontal distance. 43.75 meters. Problem 15. Vehicles arrive at stop signs at an average rate of 300 per hour. Average waiting time at the stop sign is 10 seconds per vehicle. If both arrivals and departures are exponentially distributed, what are the average queue lengths and average delay per vehicle? 0.83 minute per vehicle.